If you detonated Photon Torpedo on the ground, almost everything at a distance of 11.5 kilometers from the explosion would be destroyed, and the surface of the Earth would turn into ashes. Within a few seconds, the shockwave would take out the windows in their home. Fireball of the explosion would reach a height of 5 kilometers above the Earth's surface, and its glow would be observable from a distance of up to 1,000 kilometers. What seemed impossible yesterday could become a reality today. Scientists from the European Organization for Nuclear Research are investigating the main mechanism of photon torpedoes, antimatter. When a photon torpedo with 1.5 kilograms of antimatter explodes, approximately 50 megatons of energy in TNT equivalent is released. For example, the Tsar Bomba, which was developed in the USSR, released about 58 megatons. It was the most powerful explosion in the history of mankind. The nuclear mushroom cloud rose to a height of 67 kilometers. The Tsar Bomba weighed 26.5 tons. The photon torpedo weighs only 250 kilograms, of which the antimatter constitutes just 1.5 kilograms. But is it really possible to build a warhead with 1.5 kilograms of antimatter? In the entire history of mankind, only 500 septillion grams of antimatter have been harnessed. This is so small that you wouldn't even be able to light a light bulb for 1 second. Antimatter mining uses as much electricity as it takes to power a small city. This makes antimatter the most expensive substance on Earth. 1 gram of antimatter costs $63 trillion. But if we learn to hold at least 300 antimatter atoms every year, in 9 septillion years, we'll be able to collect 1.5 kilograms of the coveted substance. However, the photon torpedo has something more than destructive power: near light speed. The warp drive accelerates a photon torpedo to 225,000 kilometers per second. It would be enough to launch a large rock at this speed to get an explosion. When the Chelyabinsk meteorite entered the dense layers of the Earth's atmosphere, the explosive power was 500 kilotons. It weighed a ton, and its diameter reached 20 meters. But massive objects cannot move at the speed of light. To do this, you need to have zero mass. However, it's impossible to build a spacecraft with zero mass. But we could bend space-time itself around a spaceship. Imagine a sheet of paper with 2 dots drawn on different parts of it. In a linear world, you need to travel a certain distance to get from point A to point B. But if you fold a piece of paper so that both points touch, you can get from point A to point B instantly. Mexican physicist Miguel Alcubierre came up with a hypothesis that we now know as the Alcubierre drive. By placing any object in such a warp bubble, you can compress the space in front of the bubble and expand it behind it. Thus, an object with mass would move faster than the speed of light through space and time. In fact, the spacecraft could even stand still. Space itself would move around it. This can only be done with the help of antimatter. According to physicists' calculations, the formation of the Alcubierre drive requires trillions of times more antimatter than is needed for the explosion of a photon torpedo. NASA has an entire division of EagleWorks Laboratories which is engaged in the study of the Alcubierre drive, but no real breakthrough has yet occurred. Nevertheless, scientists have already learned how to teleport quantum particles over long distances. Perhaps we should stop the constant and pointless arms race and start exploring space in new ways. Who knows? Maybe in 100 years, people will be destined to meet extraterrestrial life forms and embark on a new path of development of civilization. Do science, not war. And as always, thank you for your attention.